Hi everyone, I'm AIZHENG. Today I'm excited to share my project, Machine Learning Prediction for Online Shoppers Purchasing Intention. Basically, my goal is to trying to see how well machines can guess if someone is going to buy something online. So the main idea of this project is to use machine learning to predict whether online shoppers are ongoing to make a purchase or just browsing. As we know, online shopping is highly complicated. Every business wants to turn website visitors into accurate sales, but it's not that easy. There are a huge amount of data showing that what users do on a website and when they do it. Things like which pages they visited, how long they stay, or what time of day they are active. It's just too much for human to make sense of all and find its right patients that tell us what it's going to do. That's where machine learning comes in. By training dataset and using the models on this data, it can find hidden patterns that human might overlook. With this insight, business can better target patient buyer and make smart decisions to improve sales. In this study, the research question is how can we tell who is just browsing and who actually ready to buy? There are so many visitors and their data are really complicated. So my goals were simple. First, this study is to build and train a few different machine learning models. Second, see which one is working the best. And finally, this study shares some practical tips for online business based on what we found. This study used a public dataset from the UCI machine learning response rate. It's got info from about 12,313 online shopping census, with 18 different data points for each. This data point or furniture covers things like what pages people visited, how long they stayed, and even what month it was. Our main target was to predict revenue. Basically, did they buy something or not? A key thing about this data is that most people didn't buy anything. Only about 15.6 actually made a purchase. Before I could train the models, I need to clean up the data. First, I removed 125 duplicate entries. Luckily, there was no missing data. Next, I convert things like months and visitor types into numbers so the computer could understand them. I also used the random forest model to pick the most important furnitures and drop someone because they didn't help so much. Then I hide those some extra value, split the data 70% for training and 30% for testing, and scaled it. Since only a some number of visitors actually made purchase, I used a tag called SMART on the training data to balance things out. In this study, I tried out 6 different machine learning models to see which one could predict purchase best. This includes some well-known ones like logistic registration and decision tree, as well as more active ones like random forest and XGBoost. I also test support vector machines and a simple neural network called MLP. I built all this using Python and most popular tools like scikit-learn. After training and testing the models, I want to see how well each one performed. I look at the numbers like accuracy, FE score, and ROC AUC. Since the purchase group was small, I paid extra attention to FE score and ROC AUC. On the test data, XG both come out on top. It has the best accuracy at 89% and the best FE score at 0.6866 and the best ROC and AUC at 0.9291. Random Forest was a close second. It actually did the best job at finding the most of the accurate buyer. That was called recall. After evaluating all the models, I focused on the one performs the best overall. Since XGBoost has the best score, especially for F1 score and ROC AUC, I picked it as the campaign model. Its accuracy was nearly 89%, and the F1 score was 0.6866, and the ROC was a strong 0.9291. Look at the details. It currently identifies 585 people who made a purchase. However, it also missed 178 actual buyers and incorrectly predicted that 356 people would buy when they didn't. So it's good, but not the perfect model. After picking the best model, I also look into which furnitures were most useful for making prediction. XGBoost helps with this by showing furniture importance. Page value, which measures the average value of the pages someone visited, was by far the most important, with a score of around 0.47. This means that if people spend time on high-value pages, they are more likely to buy. Months came next, suggesting that the time of the year also matters. Another factors like how people arrive at the website, their location, and how much they interaction with the pages also play a role. Moving into the discussion and implications, even though I use Mode to balance the data, the F1 score still hovered between zero point 0.6 and 0.7. This highlights how challenging it is to perfectly predict that small group of buyer. Models like XGBoost and Random Forest did better, which matches what another study have found. So all this means that, for theory, it confirms that things like page values and months really matter when predicting online shopping behaviors. For business, this can help them to find the potential customers more accurately and spend their marketing money wisely. They could focus on improving high-value pages or planning promotions around their certain months or traffic types. To wrap up this project, I found that XGBoost was the best model for this dataset. Page values was the most important clue for predicting who would buy, which means that pages with higher value are a good sign that someone might make a purchase. Overall, using machine learning really helps to understand and predict online shopping behaviors. Looking ahead, there are a few things I like to try. Using a better way to balance the data. Create a new furniture that might give the model more clue. Let the computer fine-tune itself to find the best setting. Test these ideas on different and newer datasets to see if the results hold up. Thanks so much for listening. I hope you find it interesting to see how machine learning can help us understand online shopping behavior. And I'm excited to keep exploring and improving these models in the future.